Mechanics of respiration. Respiration. It is a rhythmic biochemical process of intake of oxygen inside body called inspiration and release of carbon dioxide outside body called expiration. The oxygen combines with body glucose to release energy in the form of ATP and release carbon dioxide and water as waste products. Mechanism of respiration. Lungs are enclosed in thorax region by thoracic cage and they are separated from the abdominal cavity by diaphragm. During inspiration, thoracic cage enlarges, leading to expansion of lungs so that the air gets in easily. During expiration, lungs and thoracic cage decrease in size so that air leaves the lungs easily. This process of normal inspiration and expiration makes up the pulmonary cycle. Muscles of respiration. Muscles involved in inspiration. Diaphragm. The normal resting respiration is mediated by the downward and upward movement of the diaphragm. The dome-shaped diaphragm is attached to the lower ribs and the xiphoid process of the sternum. During inspiration, the diaphragm contracts, thereby pulling the thoracic cavity downward and pushing the rib cage outwards, thereby increasing the lung volume. External intercostal muscles. External intercostal muscles are present obliquely between the ribs. They run in a downward direction, extending from the inferior margins of the upper ribs to the superior margins of the lower ribs, thereby positioned antero-inferiorly. They aid during quiet and forced inspiration. On inspiration, there is contraction of the external intercostal muscles and the ribs elevate, expanding the transverse dimensions of the thoracic cavity. Pump handle movement of ribs. The second to sixth ribs move upwards during inspiration to achieve a horizontal position due to contraction of external intercostal muscles. This increases the anterior-posterior diameter of the chest and transverse diameter of thorax. Bucket handle movement of ribs. During inspiration, 7th to 10th ribs, that is lower ribs, swing outwards and upwards along the upper ribs, causing extra increase in transverse diameter of the thorax. Muscles involved in expiration. Abdominal muscles. During expiration, the muscles of abdominal wall contract and increase the intra-abdominal pressure, pushing diaphragm upward. The diaphragm relaxes, thereby compressing the lungs. Internal intercostal muscles. The internal intercostal muscles are located below the external intercostal muscles. They run in an upward direction, passing between the most inferior lateral edge of the costal grooves of the upper ribs to the superior margins of the lower ribs. The internal intercostal muscles aid during forced expiration by causing depression of the ribs by pulling the rib cage downwards and thus decreasing the transverse dimensions of the thoracic cavity. Accessory muscles of respiration. Scalene and sternocleidomastoid muscles are found in neck and play their role during voluntary respiration by aiding in elevation of the thoracic cage during deep respiration. When the muscles of inspiration contract, expansion of the thoracic cavity occurs. The pressure inside the lungs decreases compared to outside atmospheric pressure, which results in intake of air. When the inspiratory muscles relax, thoracic cavity reduces in size. The lungs are compressed, causing increase in the pressure inside the lungs compared to atmospheric pressure, which results in expiration of air. Pressure changes during pulmonary cycle. Intra-alveolar pressure. When there is no flow of air in and out of the lungs, the alveolar pressure is equal to the atmospheric pressure of 760 mm of mercury and is considered to be 0 mm mercury. During inspiration, the alveolar pressure drops to -1 mm of mercury, resulting in intake of air from high pressure area of nostrils into the low pressure area of alveoli. During expiration, the air flows from the high pressure area, that is, the alveoli, to the low pressure area, that is, the nostrils, resulting in positive alveolar pressure of 1 mm of mercury, forcing the inspired air to be expelled out of the lungs. Intrapleural pressure. There exists a pressure between the visceral and parietal layers of pleura called intrapleural pressure. The elastic force of the lungs pulls it inwards, bringing the visceral pleura also inwards and reducing the size of the lungs. The surface tension of the alveoli also tends to reduce the alveolar size, thereby pulling the lung inward. The elasticity of the chest wall opposes the inward pull of the lungs, pulling the parietal pleura outside and increasing the volume of the thoracic cavity. According to Boyle's law, pressure is inversely proportional to volume. Hence, due to increase in volume of the thoracic cavity, there is decrease in its pressure, thereby creating a negative intrapleural pressure. Normal intrapleural pressure is about -2.5 mm of mercury. This pressure becomes more negative during normal inspiration due to further expansion of the chest cavity, creating a negative pressure of about -6 mm of mercury. During expiration, the chest wall is pulled back to resting position and the pleural pressure retains its pressure of -2.5 mm of mercury. Transpulmonary pressure. It can be defined as the difference between the alveolar pressure and intrapleural pressure in pleural cavity. It is also termed as elastic recoil pressure of the lung. Compliance of the lungs. The lungs have the ability to stretch and expand. The change in the volume of the lungs per unit change in transpulmonary pressure is defined as the compliance of lungs. It is measured in liters per centimeters. A healthy adult lung compliance is about 0.2 liters per centimeter. If there is more change in volume per unit pressure, the compliance is high. The thoracic cage interferes with the expansion of the lungs, thereby decreasing their overexpansion. There are two types of compliance. The compliance measured under static conditions, that is by measuring pressure and volume when breathing does not take place,